the reflection of ray of light normally incident on a plane mirror. Means when a ray of light is incidenting normally on the mirror, what happens? Suppose we have considered a ray, that is a ray of light AO, which is normally incident on this plane mirror, that is MM1, and it having a point of incidence. At this point of incidence, this ray is striking. So we will see the angle of incidence here is 0 degree. According to law of reflection, we know that angle of incidence is equal to angle of reflection. Means if angle of incidence is 0 degree, so angle of reflection will be also 0. It means the incident ray will be only the reflected ray. So the reflected ray of light will be also OA. It shows that the ray of light which is normally incident after the reflection from the plane mirror will retrace its path along OA. Means what is the incident ray? That will be only the reflected ray. Now we'll study about how the image is formed by the plane mirror. First condition is when the image is formed by a point object. Means when we are considering as a point object. Suppose here this is a point object O which is placed in the front of mirror MM1. From this object, many rays of light will travel in all directions, but we will consider only two rays, that is OA and OB, which will be reflected as AC and BD from this mirror. These reflected rays, this BD and AC, these rays enters our eye, and we will think that these rays are appear to come from the image, that is eye, which is formed behind the mirror. So we can say this eye image is the virtual image of this point object. Since this image is formed behind the mirror, so this is the virtual image. So here we'll see that angle AO and angle AO, this is the angle of incidence. This ray is forming angle of incidence, and AC, this is forming an angle of reflection, in such a way that angle of incidence is equal to angle of reflection. Similarly, the angle of incidence of the ray OB, this I2, and angle of reflection BD, that is R2. So this angle of I equals to angle of R2. So to locate this position of the image, we will do, what we will do? We will, this reflected rays AC and BD, this we will produce backward. When we will this produce backward, they will meet at this point I. So this is the image of the object. And now if we measure distance of OM and IM using a ruler, we will find that OM will be equals to IM. Means the perpendicular distance of the image from the mirror, this distance which is of the image from the mirror is equal to the perpendicular distance of the object from the mirror. Means we can say the image is as far behind as the object is. जितनी दूरी में ऑब्जेक्ट होगा उतनी ही दूरी इमेज फॉर्म होगी, और इमेज विल बी फॉर्म्ड ऑलवेज बिहाइंड द मिरर व्हेन द ऑब्जेक्ट इज पॉइंट ऑब्जेक्ट. So we can say that at least two ray of incidence we need for making to find the position of object of the image by the mirror. Then ray incident which is normal on the mirror can be taken as the one of the incident rays. This is how the image is formed by the point object. The characteristics of this is it will be always a virtual image since it is behind the mirror, and the distance of the object from the mirror is equal to the distance of the image from the mirror. This distance IM will be equals to OM distance, and the size will also be same. So this is how the image is formed by the point object. Now we will discuss about the formation of image formed by the object which is of finite size. For example, I am having this pencil and a marker which is marked as, its starting point is marked as A and ending point is marked as B. So from point A we have taken two incident rays. These two incident rays we have taken from each extreme points, from A also, from B point also. For each incident ray we see, for this there is also a reflected ray which is showing from here also two incident rays showing two rays of reflection. Here also from the point B, two incident rays showing two rays of reflection. And if we measure this angle of incidence in both the cases, we will see that the angle of incidence is same. And when we produce these reflected rays backward, From here and here also we will get here 1 point, and from here also when we produce this reflected rays backward, we'll get another point. So we can say the image of the object will be formed, which is marked as A dash B dash. And if I measure the size of AB, this will be same as it is of A dash B dash. So the size of the image will be equal to the size of the object. So this is how the image is formed when the object is of finite size. So from the two images we have concluded some points, and that points are: if an object is in front of plane mirror, the image is always formed behind the mirror. Image always forms behind, and it is never obtained on the screen. How it is obtained? The image is only formed when the reflected rays are produced backward. We have seen in a point object also, in the finite size object also, that image is always formed when reflected rays are produced backward. So we can say this is the virtual image. Second, image is as far behind the mirror as the object is in front of it, the mirror. Means how much the mirror is in front, how much the object is in front of the mirror, that much far behind the image will be formed. And thirdly, we have seen the size of image is the size of object. In the second point, we have the second diagram we have studied, that is the size of the pencil is equal to the size of the image of the pencil. So what is the size of the image? That is the size of the object. Then fourth point is image is always erect. It is always erect, it is never inverted. So these are the 4 points we have, which we have concluded when the image is formed by the either point object or image is formed by the finite size object.